Welcome back for the Chapter 7 notes video. Today we're going to be introducing in this lesson the topic of confidence intervals. Hopefully you did the little extra credit assignment on this Chapter 7 intro. It's not being graded for correctness. It's really being graded for you to kind of get an idea of how we're going to tie in topics that we've learned in the previous chapters into confidence intervals. So by definition, a confidence interval is another type of estimate, but instead of being just one number, it is an interval of numbers. It provides a range of reasonable values in which we expect the population parameter to fall. There is no guarantee that a given confidence interval does capture the parameter, but there's a predictable probability of success. To construct a confidence interval for a single unknown population mean mu, where the population standard deviation is also unknown, we need the x bar as an estimate for mu, and we need the margin of error. Here, the margin of error, we're going to use the symbols ME, is called the error bound for a population mean. The sample mean x bar is the point estimate of the unknown population mean mu. The confidence interval estimate will have this form. We're going to take the point estimate and subtract the margin of error, and then also the point estimate and add the margin of error. This will be our upper. This is going to be our lower bound. And this will be the upper bound of the interval. So essentially we're taking the sample mean and subtracting the margin of error, and the sample mean plus the margin of error. The confidence level, which we'll call the C level, is the percentage of samples that are expected to include the true population parameter if you made a confidence interval for each sample. Alpha, which we use the Greek letter alpha, the percentage of samples that are expected to not include the true population parameter if you made a confidence interval for each sample. So the C level and the alpha are complements of each other. And we do have some interpretations. So the formal interpretation is if you take many samples and make a confidence interval from each one, the 1 minus alpha times 100% of the confidence intervals will contain the true value of the population parameter. The informal interpretation, which is the one that we're going to use, is this. We are blank percent confident that the true population parameter is between blank and blank. And this would be your lower bound and your upper bound. And we're going to get some practice with this. Let's look at example 1. It says, suppose we have collected data from a sample. We know the sample mean, but we do not know the mean for the entire population. The sample mean is 7, and the margin of error for the mean is 2.5. What is the confidence interval estimate of the population mean? So the sample mean is 7, and the margin of error is 2.5. So the confidence interval is going to be 7 minus 2.5 and 7 plus 2.5. And so that's going to be 4.5 up to 9.5. So this is our lower bound, and this is our upper. Now, we don't know the percentage confidence here. We will later on, but in this example, we didn't give you the percent confidence, so we can't really interpret this, but we do know that the true population parameter mean should be between 4.5 and 9.5. Okay, let's look at example 2. Suppose we have data from a sample. The sample mean is 15 and the margin of error for the mean is 3.2. What is the confidence interval estimate for the population mean? So our sample mean is 15 and the margin of error is equal to 3.2. So we're going to take 15 and subtract 3.2, and then we're going to take 15 and add 3.2. So my lower is going to be 11.8 and 18.2. Again, this is my lower and this is my upper. So we can think of this on a number line here. So if we had 0, and let's say this is 5, and this is 10, and this is 15, and this is 20. So our sample mean is here. And then there is our lower all the way up to, there's our upper. Okay, so this in here, this distance in here is our margin of error. So increasing the confidence level increases the margin of error. It increases this right here, making the confidence interval wider. So increasing the confidence will make it wider. Decreasing the confidence decreases that error bound, making the confidence interval narrower. So finding the margin of error. From the upper value for the interval, subtract the sample mean, or from the upper value for the interval, subtract the lower value, then divide the difference by 2. If you were not given the margin of error, if you were given the confidence interval. If you were given the confidence interval, you can find the sample mean by subtracting the error bound from the margin upper value of the confidence interval, or average the upper and lower endpoints of the confidence interval. Suppose we know that a confidence interval is this 67.18 to 68.82, and we want to find the margin of error. So the margin of error is either taking the upper and subtracting the sample mean, but we don't know the sample mean, or the margin of error is taking the upper minus the lower and dividing by 2. So that's what we're going to do. 68.82 minus 67.18 divided by 2. And so when we go to Desmos, so the difference is 1.64 divided by 2 is 0.82. We could also find our sample mean if we wanted. So our sample mean is going to be by adding the upper and lower and dividing by 2. So in that case, we would take 68.82 and add 67.18 and divide by 2. And so our sample mean is 68 in this case. So example, this should be example 4. Sorry about that. This should be example 3 and example 4. Suppose we know that a confidence interval is 42.12, 40 to 47.88. Find the margin of error and the sample mean. So let's find a sample mean first. We're going to do the upper plus the lower divided by 2. So 42.12 plus 47.88 divided by 2. So our sample mean is 44.96. And then our margin of error is our upper minus the sample mean. That's one way we can do it, which is going to be 47.88 minus 44.96. I typed in my This should be 45. Sorry, I typed that incorrectly. I missed a digit. So to find the margin of error is 47.88 on our upper and subtract our sample mean, which should be 2.88. Or you can also find the margin of error by taking the upper minus the lower and dividing by 2. So 47.88 subtracting 42.12 dividing by 2. Make sure that you notice the difference here. If you add them and divide by 2, you're finding the X bar or the point estimate. If you subtract them and find the difference, you're finding the margin of error. So you should again find 2.88. So this is just a little intro to the pieces and parts of the confidence interval. Catch me back for the next lesson.